right, you should have worked out the derivative of cotangent on your own. The answer is that the derivative is negative cosecant squared. If you got that and you feel good about it, feel free to move on to the next video. I've got the work up here and I'll just run through it quickly for those who want to. Cotangent is cosine over sine. So again, we can use the quotient rule. So we get sine x times the derivative of cosine minus Heidi low is cosine times the derivative of sine over the bottom squared, which is sine squared x. We get sine x, the derivative of cosine is negative sine, minus cosine x, and then the derivative of sine is another factor of cosine of x, over sine squared x. So on top now both terms are negative. We've got negative sine squared minus cosine squared x all over sine squared x. On top we can factor out that negative 1. So it's negative 1 times sine squared plus cosine squared, and of course this just simplifies to 1, so the top simplifies to negative 1. Now if you went right from negative sine squared x minus cosine squared x to negative 1 without showing this step of factoring out the negative 1, I'm totally fine with that. Okay. All right, once we have this, that's the opposite of the fraction 1 over sine x quantity squared. Okay, we're not squaring that negative, but if we square the 1, we get a 1. If we square the sine x, we get a sine squared, and then that whole thing becomes negative when we multiply by the negative. But 1 over sine x is cosecant, so what we get is the opposite of cosecant squared. Okay. So I'm just at the top here recording all of these derivatives. That's negative cosecant squared x. What I'm writing here is sort of the standard versions of the formulas. Of course, with the richness of trig identities, all of these have multiple versions. If you were to write negative 1 over sine squared x instead of writing negative cosecant squared x, that's totally fine. It's right. It's equivalent. It's just a different way of writing this. I'm just writing the versions of the formulas that are considered the most standard. If all we were ever doing was taking derivatives, I would recommend that you memorize these two, and I wouldn't care whether you memorize these two and the derivatives of secant and cosecant, which we'll work out in a moment, because it's fairly quick to go through this. What I would probably say is if all we were doing was taking the derivatives, make sure you know these two, because these were time consuming. Just derive the others as you need them, and you'll probably find that you accidentally memorize them at some point. However, we're not only going to be taking derivatives. At some point in this semester, we're going to try to reverse that process. Because in math, pretty much every time you learn how to do something, you later learn how to undo it. Okay? We're just always just going in circles and doing and undoing things. That's what we do. Okay. So at some point, you're going to be given the function secant squared and say, that's the derivative of some function. What is it the derivative of? That's a hard question if you don't have this formula memorized. It's an easy question if you do. So you should know, without having to do any work, the derivatives of all 6 trig functions. Of course, once we finish deriving them. Okay. Now, I think the best way to do that is to just derive these enough times that you accidentally memorize them and use them often enough. But I would derive them a couple more times, because sometimes what happens is after you accidentally remember something, you accidentally forget it. If you remember that quotient rule is how you got them, you can get them back again fairly quickly. But you are going to want to have these formulas at the tip of your fingers for the time when we start reversing this process and saying, here's the derivative, what was the original function?